So we talked about binary acids, and the other type of acid is an oxyacid. So we identify oxyacids because they contain oxygen. So these have oxyanions in them, those nitrate, sulfate, phosphate type things. So oxyacids come from oxyanions. So when we look at the formulas for these three acids, HNO3, the H at the beginning of the formula tells me this is an acid. And then when I see oxygen in it, I say, this is an oxyacid. It has oxygen in it. The binary acids also start with H, but they don't have O in them. Okay? So HNO3 has the nitrate ion. So if I cover up the H, you see the NO3 there? H2SO3, if I cover up those H's, I've got SO3. That has the sulfite ion in it. You see that? Sulfate is hiding in this acid, SO4. The number of hydrogen ions that are in the acid depends on the charge of the oxyanion. So with this H2SO4, what we have is we have hydrogen ions and sulfate ions that get formed when this molecular compound dissolves in water. It forms ions. Well, if I want these charges to add up to 0, I need 2 hydrogens. So I need H2SO4. That's why the formula is H2SO4, because it takes 2 hydrogen ions to balance the charge on the sulfate ion. Are you okay with that? The pattern for naming oxyacids is a little different. Their names are based on the names of the oxyanions. So if the oxyanion ends in ite, like sulfite or nitrite, we change ite to us and add the word acid. If it ends in ate, you take that ate ending and change it to ic and add the word acid. So how do you remember that? This is a silly sentence that I learned. Rick ate him before he could bite us. Sounds a little violent, doesn't it?
Sounds like something from Florida.
Yeah, that homeless guy. Good grief. Rick ate him before he could bite us. So ite and us go together. Ick and ate go together. There's another one I've seen. The white mouse ate icky cheese. White mouse. There's the us. Ate icky cheese. So I'll tell you about that one, but that's not one that I usually use. So ite and us go together. Ick and ate go together. So here are some of the common oxyacids. Here we have a table. We're showing the acid formula, the acid name, the name of the oxyanion, and the formula of the oxyanion. So when we see this formula, HNO2, that has the NO2 ion in it. NO2 is named nitrite. To name the acid, I change ite to us. So I get nitrous, and I put the word acid at the end. HNO3 is very similar to HNO2. It has the nitrate ion in it. So the name comes from nitrate. I change the ate ending to ic, and it's nitric acid. Some of them end up, they're like, oh, I'm not sure exactly how to say that, but they all follow this nice pattern here. This one looks really messy, doesn't it? HC2H3O2. Oh my goodness, there's too many letters. We'll just cover up the first H and look at what's left. C2H3O2 is the acetate ion. So acetate ends in ate. You change the ate to ic. Acetic acid. Okay? Any questions? Let's do a couple of examples. So HNO2. When we're naming acids, we recognize them because they start with H. So cover up the H and look at what's left. Here I have something with oxygen in it. I need to name that. So I look at NO2. I can tell from the number of hydrogens that it has a -1 charge, or because I've memorized those polyatomic ions. What's the name of that? This is nitrite ion, sorry. My kids gave me their cold. So this is nitrite ion. So we're going to change ite to us. Rick ate him before he could bite us. So nitrite becomes nitrous acid. So it's named based on the name of the polyatomic ion. How about this one? HClO4. Cover up the H. What's the name of what's left? It's similar to chlorate. This is chlorate. Perchlorate, because it's got one more oxygen. So it's got ClO4. So this is from the perchlorate ion. I'm just going to change the ate ending to ic. And then add the word acid. So I've got perchloric acid. Okay? Naming acids gives students a lot of trouble, but there is a very nice pattern here. So if you just keep working at it, it'll click for you eventually.